Hi everyone, welcome to section 6.5 where we're talking about polynomial equations. And the goal of this section is we're going to use a zero product property. We're going to solve quadratic equations by factoring. We're going to solve equations with polynomial functions and possibly some applications. Okay, so let's get started. First of all, what's a polynomial equation, right? It's an equation that contains an expression. So let's say, for example, you have like 3x cubed plus 2x squared plus x plus 7 equals 5 or something. That's an equation because it has an equal sign, okay? And then the degree of the equation would, of course, be the degree of the polynomial. And, of course, we know that the degree of the polynomial is the highest exponent for each term, right? In particular, we're going to focus on quadratic equations. So quadratic equation has this form ax squared plus bx plus c, where you have the coefficients are real numbers, and of course the first one cannot be 0 because it has to have a square term. Now, the way that we solve quadratic equation, and then a lot of polynomials actually, we use what's called the zero product property. Now, we're not in person, but if we had, and one thing I like to ask people is, think of two non-zero numbers that when you multiply them, it equals 0. Can you think of any? So if you can't think of any, that's because there aren't any. In order for a product to be 0, one of the numbers has to be 0, right? Either A equals 0 or B equals 0 or both. And that's what that is. Okay, and if you question that, go ahead and try it. Try finding two non-zero numbers whose product is equal to 0. It's kind of, you won't be able to because it doesn't exist. Anyway, so how do we use this zero product property? So when we factor quadratics or any other polynomials, we solve for the variables by taking each factor and setting it equal to 0. So let's say here we have a factored polynomial equation, and because it's equal to 0, the product is equal to 0, each of these can be set equal to 0 to solve for n. So that equals 0, 5n minus 2 equals 0, and 6n minus 1 also equals 0. So then to solve for n, we just go ahead and solve like we normally would. So this cancels out. We get 5n is equal to 2, divide by 5, and n is equal to 2/5, okay? Next one, we add 1 to both sides, and then we get 6n is equal to 1, divide both sides by 6, we get n is equal to 1 over 6. And those are your two solutions for this equation. Okay, so next, how do we solve a quadratic equation by factoring? So first of all, we need to write it in standard form where you have the quadratic expression on one side, then the equal sign, and then 0 on the other side. Now, when we factor this, we can use zero product property and solve for the variable. So let's go ahead and do that. So first of all here, this isn't in the right form, right? We have 2y squared is equal to 13y plus 45. So we would subtract 13y from both sides. So we get 2y squared minus 13y, because they're not like terms, is equal to 45. So then we need to set this equal to 0. So let's go ahead and subtract 45 from both sides. So finally, on the left-hand side, we get 2y squared minus 13y minus 45, and then that's equal to 0. So let's go ahead and use AC method, I guess. So A is 2, C is negative 45. So AC is equal to negative 90. What are the factors of negative 90 that when combined give me negative 13? So then you can kind of think about, okay, one has to be negative and one has to be positive, right? So we have lots of possibilities. You could have the factors of 90. You can have 3 times 30. We have 15 times 6. We could have 10 times 9. We could have, let's see, what else? So, and one of them has to be negative. So 2 times 45 is also a possibility. And I'm thinking, is there any others? 5 times something, right? 5 times, let's see, 18. Oh, there it is. 5 times 18. So 5 times 18. So negative 18 times a positive 5 gives me negative 90. And then added together give me negative 13. So that's okay. So now we need to rewrite this equation. So I'm going to write it over here. 2y squared minus, and instead of 13y negative, I'm going to write negative 18y plus 5y minus 45, and that's equal to 0. Then factor by grouping. So then that gives me 2y, and that's y minus 9. Then the next to 5, that gives me y minus 9, and that's equal to 0. They have y minus 9 in common, so my two factors are y minus 9 and 2y plus 5. So now I've factored it on the left-hand side, and by zero product property, I can set each factor equal to 0 to solve for the variable. So I have 2y minus 9 equals 0, and 2y plus 5 is equal to 0. So solving for y, we get y is equal to 9 for one of them. And then on the other side, we have here 2y is equal to negative 5 divided by 2. And we get that y, y is equal to negative 5 halves. Okay, so that's that one. Let's say we have something like this, where we have 169q squared is equal to 49. So let's solve, let's set it equal to 0, minus 49 from both sides. We get 169q squared minus 49 is equal to 0. This is a difference of squares, right? So it's 13q minus 7, 13q plus 7. That's equal to 0. Zero product property. 13q minus 7 equal to 0. 13q plus 7 is equal to 0. And so go ahead and let's solve for q. So we add 7 to both sides here. We get 13q is equal to positive 7 divided by 13. And so one of the answers is 7 over 13. On the other side, subtract 7 from both sides because this is positive. 13q is equal to, that's q, negative 7 divided by 13. And then the other solution is negative 7 over 13. So those are our two solutions for q. Okay, what about this one here? We have, it looks like it's factored already, but is it set equal to 0? No. So now we have to multiply it out, subtract both sides by that 3x, so we do get that 0 on the side of the equation that we want, combine like terms, and then factor again. Okay, so let's go ahead and do that. So 3x minus 8 times x minus 1 is going to end up being 3x squared minus 8x minus 3x plus 8. So then that's going to be 3x squared minus 11x plus 8 is equal to 3x. Subtract 3x from both sides. Okay, and we get 3x squared minus 14x plus 8 is equal to 0. So then let's go ahead and factor this. So 3 times 8, so AC method, 3 times 8 is 24. Two factors of 24 that when combined give me negative 14. That would be negative 2 and negative 12, because when I multiply those two together, I get a positive 24. And when I combine those two, I get negative 14. Okay, fine. So let's rewrite that. Remember what we're doing. We're, instead of having the middle term being negative 14x, we're replacing it with this, okay? That's why it works out when we do factor by grouping. Okay, and then don't forget to include the x, of course. Plus 8 is equal to 0. So now factor by grouping. The first two have a GCF of x. That leaves us with 3x minus 2. The second two, I'm going to bring out this negative. It has a GCF of 4. That gives me 3x minus 2, and that's equal to 0. So now the common factor, 3x minus 2, comes in front. What's left over is an x minus 4. And now, my friends, this is factored, and it's factored in the way that we want it, where it's equal to 0. So now what do? We use the zero product property. And we set each of these factors equal to 0, like so. and we solve for each x. So here we have 3x is equal to 2 divided by 3, and then one of our solutions will be 2/3. It's a 3 right there. And then the other one, we solve for x here, and x is equal to 4. Okay, let's see here. Here's a different type of problem that could be given to you. Suppose you have the function f of x is equal to x squared plus 2x minus 2. Can you find x when the value f of x is equal to 6? So what does that mean? Okay, so literally what that means is here f of x is equal to 6. So we take that and we say 6 is equal to x squared plus 2x minus 2. So you see what we did here? Because they told us f of x is equal to 6, instead of f of x, I'm writing the 6. Because they're equal to each other, I can do that. I can substitute like that. Okay, so now it's just a matter of making this 0 plus 2x minus 8 and then factoring, right? What are the factors of -8 that when combined give me +2? If you said -2 times +4, you were correct. So then that's going to be x minus 2, x plus 4 are the factors of this trinomial. And then zero product property, x minus 2 is equal to 0, x plus 4 is equal to 0. And then simplify, right, or solve for x. X is equal to 2, and x is equal to -4. So remember, you might remember or you might not remember, is that here a parabola can cross the x-axis twice, and that's usually what's going on here. You have a parabola that crosses at x equals 2 and x equals -4. But what if you wanted to find the exact point where that happens? So what you could do is you can plug these in to f and then find what the, find the y value. So in this case, we already know what the y value is actually. This is probably super convenient because the y value at any intersection is 0. So this point is 2, 0. And this, -4, 0. And this point is 2, 0. So for B, it's really easy. We can just use results from A. So x equals 2, y is equal to 0. X is equal to -4 and y is equal to 0. So again, that's because of this here, right? We set it equal to 0. Okay, so that leads us to this next definition. 0 of a function. For any function f, if the function itself is equal to 0, then the value of x that makes that function 0 is called a 0 of the function. Now, so don't get confused, okay, in the sense that the x itself is not always necessarily 0. It means the value of the function is 0, okay? So you'll see as we go along that in math, sometimes the same exact concept has like many different names. And there's a reason for that. It's probably because it was defined in context of another situation, but solutions for quadratics can be called roots, they can be called zeros, they can be called x-intercepts. Those are all talking about the same thing. So, in one way you could look at it as, well, I'm not really learning much new things. I'm just learning the same thing, but it's called a different thing. It's called a different name. Okay, so anyway, here we go. So for this function here, let's find the zeros of the function. So all that means is, okay, f of x is equal to 0. Plus 10x minus 8. So now I need to find the appropriate x's. So AC method, we can do -24. What are the factors of -24 that when I combine them I give +10? So if you said -2 and +12, you were right. So let's continue. Substitute 3x squared. -2x plus 12x minus 8. Okay, factor by grouping. X, 3x minus 2 plus, and then factor out of 4, we get 3x minus 2. So then finally, 0 is equal to 3x minus 2 times the quantity x plus 4. Okay, now we can use zero product property. Zero product property, 3x minus 2 is equal to 0, and x plus 4 is equal to 0. So solve for x. We get x is equal to 2/3, and x is equal to -4. So those are our zeros. Okay, so the zeros are -4 and 2/3. So that's the same as the x-intercepts. So the x-intercepts are the same thing. So you have 2/3, comma 0, -4, comma 0. So that one's easy. And then any y-intercepts. Now y-intercepts is different, right? Y-intercept of a function, it occurs when the value of x is equal to 0. And I'll show you how come by looking at this picture here. So let's say I have this function, some kind of parabola. It crosses here at the y-axis. That's why it's called the y-intercept, because it's touching the y-axis. Remember, this is the y-axis and this is the x-axis. Okay, what's the value of x at any y-intercept? Well, it's 0, yeah? So in order to find a y-intercept, we need to let x equal to 0. And analogously, of course, if you're finding an x-intercept, the y value needs to be equal to 0, which is what we've been doing anyway, yeah? Okay, fine. So let's go ahead and do that. So we want to find the y-intercept. So we want to find y. So instead of f of x, I'm going to write y is equal to 3 times 0 squared plus 10 times 0 minus 8. So of course, all these zeros make the following two terms equal to 0. So y is just equal to -8. And that's your y-intercept. It occurs at 0, comma, -8. Okay. All right. So we're going to talk a little bit about word problems. So how would we use this to solve word problems? Of course, we know the steps. We need to read the problem, make sure we understand all the words and ideas. Then we go from there. We identify, hey, what is the problem asking me? That's usually what your variable is, okay? Like if it says how long or how far or how fast, okay? That means your variable is going to represent time or distance, you know, or rate, okay? So then you need to name that, choose a variable, translate it into equation, and make sure that we cover everything and then solve the equation. So I think we've done this before. Product of two consecutive odd integers is 323. Find the integers. Remember that let's say the first consecutive odd integer, so the first odd integer, we're going to let that be x. So then the second consecutive odd integer is going to be 2 more after that. So we can use x plus 2 to represent that. Now it says the product, so x times x plus 2 is, so directly translated means equals, and then 323. So see, we've taken that sentence and we've described it using symbols, right? Algebra, variables. So it's nice. So let's go ahead and simplify here. We can get x squared plus 2x. Subtracting 323 from both sides gives me a minus 323 here, and that's equal to 0. So now we can factor. What are two integers whose product is negative 323, but when added together give me 2? So it's probably something closer to 323, or around the middle, right? Let's see. What are the factors of 323? Let's see. 323. Just a second. Let's see, 323. Let's see, 323 divided. Okay, 17 and 19. So 17 times 19 is equal to 323. So it has to be a positive 2. So positive 19 times a negative 17 give me a positive 2. Gives me 323, but when combined, give me positive 2. So then your factors are x plus 19 x minus 17. That's equal to 0. So solving for x, and then you have x is equal to negative 19 on one end. So if x is equal to negative 19, the next one after that is going to be negative 17. So then if x, wait, no, actually, sorry. If x, yeah, negative 17. Negative 17, sorry. And then the next one is x minus 17 is equal to 0. So solving for x, we get x is equal to positive 17. And then what's the next consecutive odd integer after that is positive 19. So you have the positive case and then you have the negative case, right? So those are your two sets of integers in that case. So let's do another problem. We have a rectangular bedroom that has an area of 117 square feet. The length of the bedroom is 4 feet more than the width. So let's say that's width. And then the length is 4 feet more than that, okay? So what is the formula for area of a rectangle? It's length times width. So since the length is 4 feet more than the width, we can plug that in. So the area is equal to W plus 4 times W. But it gives us a number for the area, 117. So then 117 is equal to, let's distribute this from the right, W squared plus 4W, solving for 0, right? We're getting 0 on the left side of the equation. We get W squared plus 4W minus 117. So let's go ahead and factor that. What are two factors of negative 117 that when combined give you 4, positive 4. So let's go ahead and figure that out. So 117, let's see, 117, maybe 13. 117 divided by 13 is 9, and there it is. So we have 13 and negative 9, because 13 times negative 9 gives me negative 117, and 13 plus negative 9 is equal to 4. So then my magic numbers are W plus 13, W minus 9. Okay, 0 product property now. W plus 13 equals to 0, and W minus 9 is equal to 0. So the first answer is equal to negative 13, but that's an extraneous solution because in our world, right, we don't have negative distances. You don't get like sucked into, we're not in space where black holes exist and matter can be sucked into itself. So we're not in that. So we can eliminate this negative, okay? So our final answer will be the width is 9, but the length is 4 more. So length is equal to 9 plus 4, so that's 13. So we have the width is 9 feet and the length is 13 feet. Okay, one final example using one of my favorites, Pythagorean theorem, which of course, as you know, is the relationship between the legs of a right triangle and its hypotenuse. Okay, so I'm not sure, I probably have told you already, but the Pythagorean theorem has a very rich history, beginning with, it used to be this huge secret, and when it first was discovered, they weren't allowed to tell anybody. It was kind of like a cult. The Pythagoreans, they were this kind of like spiritualist mathematicians, and if they told anybody the theorem, they actually it was not to be shared with, like, under threat of death. You know, like if you shared it, they killed you. That's crazy, right? Anyway, that was a long time ago, and now everybody gets to use it. So anyway. Remember, this is the leg. This is considered a leg as well. And the longest side is called the hypotenuse. Okay, just let's see here. So let's look at this example. A boat sail is in the shape of a right triangle. The hypotenuse is 17 feet long. The length of one side will be 7 feet less than the length of the other side. So see, we labeled the other side X, and the one side will be X minus 7, okay? So find the lengths of the side of the sail. We have A, B, C. We just plug it into the Pythagorean theorem. So we have X minus 7 quantity squared plus X squared is equal to 17 squared. So If we multiply this out, we get x squared minus 14x plus 49 plus x squared, that's equal to 17 squared, which is 289. So combining like terms, we get 2x squared minus 14x plus 49 is equal to 289, but subtracting both sides by 289, we get finally 2x squared minus 14x minus 275, and that's equal to 0. So see, we set it equal to 0 so we could factor. So okay, again, AC method. So 2 times 275 AC is 550. Remember AC method. So negative 550. We want the factors of negative 550 that when combined give me negative 14. So you might have to just, on the side somewhere write down, okay, what's negative 550? What are the factors of it? That would be what? Negative 55 times 10. What else? 5 times 110. That's probably too large. Let's see. 550 divided by, let's see, 11. What's the difference? Nope, that's too much. How about, let's think. 550, 11, 2. How about what else can go into 550? So 550 divided by 50. That's 11. We just did that. Okay, fine. I know it exists. So let's see, 550. Oh, here we go. How about 22? 22. 25. That's a difference of 3. That's too much. Divided by, let's see, 22, 24, that's 8. 550 divided by 8, maybe? Nope, just kidding. 550 divided by 24, that's 550, 25. 550 divided by, let's see, T? No. D divided by, I'm sorry. Just give me 1 second. I should have probably done this before. Okay, just a second. Let's see here, 550. I don't know. So 15. Oh, I see what happened. We didn't divide by. Wait. Oh, I'm so sorry. I messed up here. I don't know why. I'm so sorry, guys. 2x squared, and that's why it didn't work. 15x minus 240 is equal to 0. And then now this has a GCF of 2. That becomes x squared minus 7x minus 120 is equal to 0. Now we can go ahead and do this. My apologies for the delay. We have negative 120, factors of negative 120 that when combined give me a negative 7. So that's going to be 15 and 8, negative 15. So that's going to be 2x minus 15 x plus 8, that's equal to 0. So solving for x, this is going to give us a negative answer, so we don't need that. So let's just go ahead and keep this one. So x minus 15 is equal to 0, so we get x is equal to 15 by adding 15 to both sides. So that's one side, and then the other side is 7 less, so that's going to be 15 minus 8, which is 7. So the other side is 15 minus 8, which is equal to 7. 15 minus 7. Oh my goodness, you guys. 15 minus 7 is equal to 8. So we have 15 and then 8. Okay, and that's it for this, mercifully. This is the end of this section. Happy studying. There's your homework. Good luck, and I will see you in the next video.